Hello everyone. In today's demo, we will be discussing hydrostatic pressure and the application of Pascal's principle in order to understand how fluids behave under pressure. Now before we begin our demo, notice that the cylinder here is connected by this tube to the other 4 tubes here. At the same time, it's also important to note that the level of the fluid in the cylinder is roughly the same as the level of the fluid in these other 4 tubes. Now we'll begin by lifting this cylinder slowly and watching what happens. So there are two things happening here. The first thing is that when we lift the cylinder, we are essentially increasing the depth of the fluid inside that cylinder. This, as a result, will also increase the pressure on that fluid in the cylinder. This is known as hydrostatic pressure. So the second thing that's happening here is that the depth of the fluid in the other 4 tubes also increase. This happens as a result of a concept known as Pascal's principle, which states that anytime there's a pressure change in one part of an enclosed system, that same pressure change will affect the other parts of that same enclosed system in order to maintain equilibrium. Thus, in our demo here, when we've seen how the pressure increased in the cylinder, then that same pressure increase happened in the 4 other tubes, which ultimately led to the increase in the depth of the fluid in those 4 other tubes. Now, since we're on the topic of hydrostatic pressure, I wonder, can you guys tell me of a moment where one may need to consider or even apply this concept? If you thought about submarines, then we're on the same page. We've now concluded our demo of this week. I hope you guys enjoyed all the material we presented to you. Stay safe.